Alright, there are other kinds of roots. We were talking about square roots. There are cube roots, and we'll talk about a cube root. What is a cube root? Well, the cube root of a number x is a number such that when it is cubed, it's equal to x. And the cube root is written as with a little 3 in front of the root symbol. And by the way, whatever number you have in front here, we call that the index. In the square root case, we don't have a number. It's understood the index is 2. But in a cube root, we will have a 3 in front of that root. And anything under a root, whether it be square root, cube root, or fourth root, fifth root, is called a radicand. Okay, so the cube root is of a number. When you cube it, you get back the number x, or whatever number you're talking about. Let's take a few examples. So, if we want the cube root of 8, that's 2. Why? Because 2 times 2 times 2, 2 to the 3 power, 2 cubed gives me 8. So the cube root of 8 is 2. Similarly, and slightly different from the square root, we can cube root negative numbers. Why? If the cube root of negative 8, for example, is negative 2. Why? Because negative 2 times negative 2 times negative 2 will give me that negative 8. So we can cube root negative numbers. And the cube root of a negative number is also a negative number. So remember that. A cube root of a negative number is a negative number. Let's take a few more examples. We see here the cube root of 27 is 3, because 3 times 3 times 3 gives me 27. 3 cubed is 27. Similarly, the cube root of negative 64 is going to be a negative answer. We said the cube root of a negative number is a negative number, and it is negative 4. Why? Because negative 4 cubed would give me 64. Cube root of 125 is 5, because 5 times 5 times 5, 5 times 5 is 25, times 5 is 125. So because 5 cubed is 125, the cube root of 125 is 5. These are what we call perfect cubes. Again, if you want the cube root of a number that's not a perfect cube, then we're going to have to use the calculator, which we'll see in a minute. There's several ways to get a cube root on a calculator. The first methods involve pressing the math button, and if you scroll down to this one, it says cube root. If we want the cube root of, let's say, 100, I hit that, enter, then I press 100, close the parentheses and enter again. There's my cube root, 4.6415888834. Now, on the calculator, if you hit math again and you scroll down, you notice there's an x root. That's for any root. So if I clear out of this, let's say I want the cube root of 100, I'd go 3, then math, and I could use this button instead. 3 is the x, enter, put my 100 in, and enter, and there's my cube root. So this x root will take any root, square root, fourth root, fifth root, sixth root. Now the one last method is a radical. If we raise 100 to the 1/3 power, so raise to power key, parentheses 1 divided by 3, that's the same as taking the cube root of 100. And enter, we get the same thing. So this is a radical. The 1/3 power is the cube root. The 1/2 power would be the square root. The 1/4 power would be the fourth root, and so on. Okay, here we have some other roots. We had square roots, we looked at cube roots, but you can have other power roots. We could have fourth roots, fifth roots, sixth roots, seventh roots, and so on. So what is the fourth root? Let's look at the fourth root of 81. That's a number when you multiply, when you have 4 of them, to whatever to the 4th power, it's going to give you 81. So if you think about that closely, that's going to be 3, because the 3 times 3 times 3 times 3, that's 3 times 3 is 9, times 3 is 27, times 3 is 81, is 81. So 3 to the 4th power is 81. So the 4th root of 81 is 3. Fifth root. The 5th root of 32. What's that going to be? Well, that's actually 2. Because 2 to the 5th power is going to be 32. 2 times 2 times 2 times 2 times 2 gives you 32. What about the fourth root of negative 256? Now, you want to know a number when you raise it to the fourth power, what get back 256. If you think clearly about exponents, there is no number when you raise it to an even power that you get a negative number. So, if your radicand is negative, you can't have an even root. So negative radicands do not have even roots that are real. There won't be real roots. There's something called imaginary numbers. We won't get to that right now. So we can't do this. This doesn't exist. This is not a real answer. However, if I took out the negative and I wanted the fourth root of positive 256, well, that's just 4. Because 4 times 4, 4 to the fourth power is 256. 4 times 4 is 16, times 4 is 64, times 4 is 256. Now, how do we work this with variables, with x's and y's and a's and b's? Let's take some examples. So here we're putting in a variable into our radicand, the square root of x squared, and we're going to say the square root of x squared is x. Why? Because x times x gives me x squared. Now technically, that's only if x is greater than 0, because we're looking for the positive root here, the positive square root. It's understood as positive if there's no negative in front of here. So to be more correct, we should actually say the square root of x squared is the absolute value of x. Now, most of the time in this chapter, we're going to actually assume that x is positive, or y is positive, or z is positive. But this is the more correct assumption here, the more correct equation, if you like. The square root of x squared is always the absolute value of x, to just take care in case x were negative. Let's take some more examples of this. The square root of y to the sixth. Well, that's y cubed. Why is that? Because y cubed, if I square y cubed, what do we get? From the laws of exponents, we multiply exponents. Y cubed squared gives me y sixth. So that's why this is true. Similarly, what is the square root of 4z squared? Well, the square root, we do it separately. The square root of 4 will give me 2. And the square root of z squared is z. And think about it. If I multiply 2z times 2z, or 2z all squared, we would get 4z squared. So the square root of 4z squared is 2z. We're going to use this idea of simplifying these radical expressions as we move on into the next section.